Hello dear students, how are you? Today we are going to discuss about Homo and Lumo. What is Homo and what is Lumo? We discuss in this video. Before this, I remind you, if you are new to my channel or if you did not subscribe my channel, please subscribe my YouTube channel, watch videos and share videos among your friends. Now we are back to our topic. Let us see what is Homo and what is Lumo. Right? Homo means highest occupied molecular orbital. Lumo means lowest unoccupied molecular orbital. We take example of 1,3-butadiene. This is our 1,3-butadiene. We can also write this 1,3-butadiene like this. In 1,3-butadiene, there are two pi bonds. This is first one and this is second one. Each made up of two p orbitals. In 1,3-butadiene, there are two pi bonds, right? Each made up of two p orbitals, right? It means there are four atomic orbitals, right? We expect four molecular orbitals, right? I once again repeat, in 1,3-butadiene, there are two pi bonds, each made up of two p orbitals. It means there are four atomic orbitals. We expect four molecular orbitals. There is a simple trick for this. You can also follow this trick, right? There are four carbon atoms, right? We expect four molecular orbitals, right? There are four electrons, right? If there are six carbon atoms, then we expect six molecular orbitals, right? And there are six electrons, right? Now we discuss this one, 1,3-butadiene. There are four carbon atoms, four molecular orbitals, four electrons. These four molecular orbitals are psi1, psi2, psi3 and psi4, right? Now we draw these orbitals. These are four molecular orbitals. This is psi1, this is psi2, this is psi3 and this is psi4, right? Now there are nodes. To calculate nodes, there is a simple trick. You can say that there is simple formula. What is formula? This is psi n minus 1, right? There are how many nodes? Psi n minus 1. Here psi n is equal to 4 minus 1. It means there are three nodes. In this case, n is equal to 3 minus 1. Two nodes, right? In this case, n is equal to 2 minus 1, 1 node. In this case, n is equal to 1 minus 1, 0 node. I once again repeat, to calculate nodes there is a simple formula. You can use this formula, right? This is also a simple trick. Sin minus 1. In this case, psi is 4 minus 1, 3 nodes. In this case, n is equal to 3 minus 1, 2 nodes. In this case, n is equal to 2 minus 1, 1 node. In this case, n is equal to 1 minus 1, 0 node, right? So psi 1, 0 node, psi 2, 1 node, psi 3, 2 nodes, psi 4, 3 nodes, right? Psi 1, 0 node, it means all lobes have same sign, right? These are lobes. 0 node. In this case, 1 node. Right? This is our node, right? What is node? You can say that node is the point between two different lobes, right? You can see here, these are two different lobes, means these two lobes have different sign, so there is a node between these lobes. If there are same lobes, there is no node. In this case, two same lobes, no node. In this case, two lobes are different, there is one node, right? I once again repeat, you can say that node is the point between two different lobes, right? Psi 3 have two lobes, sorry, psi 3 have two nodes. These are two nodes, right? Node is nothing. You can say that node is the point between two different lobes, right? Now psi 4 have three nodes, right? These are nodes, right? In case of psi 1, last two lobes have same sign. We can say that this is symmetric, right? Psi 2 have two lobes which are different. We can say that psi 2 is asymmetric. Here, last two lobes have same sign, symmetric. In this case, last two lobes have different sign, so asymmetric, right? If last two lobes have same sign, it means symmetric. If last two lobes have different sign, it means asymmetric, right? In this case, same sign, symmetric. Last two lobes have different sign, asymmetric. In this case, last two lobes have same sign, symmetric. In this case, last two lobes have different sign, asymmetric, right? Now there are four molecular orbitals. There are four electrons, right? If we talk about thermal reactions, means under thermal conditions, these four electrons are like this, right? Under thermal conditions, we can fill these electrons like this, right? Now these are two orbitals, two molecular orbitals which have electrons, right? This is lowest occupied molecular orbital and this is highest occupied molecular orbital, right? We can say that this is HOMO. Psi 2 is HOMO under thermal conditions, right? These are two orbitals, means psi 1 and psi 2 are two orbitals which have electrons. This is lowest occupied molecular orbital and this is highest occupied molecular orbital, right? Now these two orbitals, means psi 3 and psi 4, don't have any electron, so this is LUMO, lowest unoccupied molecular orbital under thermal conditions, right? And this is highest unoccupied molecular orbitals under thermal conditions, right? If we talk about photochemical reactions, means when light is absorbed by molecule, what happens? One electron from psi 2 jump to psi 3, right? Now these three orbitals have electrons, psi 1, psi 2 and psi 3, right? Now this is psi 3 is HOMO, right? Means these three orbitals have electrons under photochemical conditions. This is lowest occupied molecular orbital and this one is highest occupied molecular orbital. Now in case of photochemical reactions, psi 4 is the only orbital which don't have any electron, so this is LUMO, right? We can say that under thermal conditions, psi 2 is HOMO and psi 3 is LUMO, right? I once again repeat, if we talk about thermal reactions, means under thermal conditions, psi 2 is HOMO and psi 3 is LUMO, right? If we talk about photochemical reactions, under photochemical conditions, psi 3 is HOMO and psi 4 is LUMO, right? I once again repeat, under thermal conditions, psi 2 is HOMO and psi 3 is LUMO, right? Under photochemical conditions, one electron from psi 2 jump to psi 3. Now under photochemical conditions, psi 3 is HOMO and psi 4 is LUMO, right? So this was all about HOMO and LUMO. I hope you understand now what is HOMO and LUMO.